Okay, so this lab is the Defining a Metal lab. I'm just going to show you the actual reaction so that you can then take your initial and final observations yourself. I'm going to hold everything up to the camera so that you can see it. And I'm going to go in order of the elements listed on the side. So hopefully that will help a little bit. Okay, so just to give you, and I would suggest maybe pausing if you need to, what it looks like before they're mixed. The first one we have is magnesium. It's called magnesium ribbon because it's just a strip of metal sort of thing. Okay, so when we add the hydrochloric acid to it, already, right away, it starts to fizz and bubble right away. So, and it's even getting a little warm as it's reacting. So initially, it starts to react right away, right? And so we know it's reacting because of the bubbles that are taking place. So we're supposed to let that sit for about 5 to 10 minutes. So we'll come back after we do all of them and see where we are. Okay, so the next one we have is sulfur. Sulfur, I have it in a powder form. It's yellow. You might know sulfur to smell like rotten eggs. So here it is in powder. When we add the acid to it, nothing starts to happen right away. It's just kind of, now it looks wet kind of thing. So nothing happened initially for this reaction. We should probably look at it again in a little bit. Okay, next one is aluminum. And aluminum is just a very small piece of aluminum wire that I got for this lab for today. So it's very, very small, as you can see. Okay. And put it in the test tube. I can smell that sulfur, that's for sure. Okay, so initially it doesn't get bubbly like the magnesium did. It just kind of looks like it's now in liquid. So nothing really happened at the beginning yet for aluminum. Okay, next one we have is silicon. Silicon, it's very, very shiny. You can see that. And so I have 3 pieces because that's what I was able to grab when I grabbed them. So adding the acid to it, it does not get bubbly like the magnesium did at first. Doesn't really seem to have anything happening yet, so we'll check back in with that one. And last but not least, we have zinc. So zinc, it's called mossy, so it's kind of just a little piece of metal like so. Okay. This one doesn't react violently like the magnesium did, but we will see what happens. So back to the magnesium, because it's still reacting very well. It is very warm now when you touch the sides of the test tube for the magnesium. The strip is not on all the way yet, but it might eventually go. So we'll wait about 5 minutes and we'll come back and check and see what happens. Okay, so I have let it sit for about 7 to 8 minutes. Turned it back on so that you can see a little bit better what's happening in the test tubes. No, that's kind of hard to see. So now we're going to look at the final observations, things you can put in that section. So first we have the magnesium. So the magnesium, actually, I hope you can see it. I know there's a glare. The metal has been eaten away. It's now almost looking like a triangle shape instead of the strip that it was before. But the test tube got very warm when it was dissolving. So the metal, and it looks like the metal is still reacting a little bit. I think if I added some more acid in there, it would react even further. Next one we have is sulfur. So the sulfur looks the same. Sulfur didn't do anything. There's no bubbles in there at all. It just sank to the bottom and is the same exact thing. Next, we have aluminum, which it's probably very difficult to see. Here, let me try to zoom in a little bit. There are little tiny bubbles starting on the sides of the wire. So it is starting to react, but it's reacting very, very slowly. And it might be very hard to see on the video. I'm sorry about that. Next one, silicon. This one looks like it's starting to have some bubbles too, but they're very, very small bubbles. So that's very, very slowly reacting, kind of like the aluminum. And then the zinc, I could see from my computer screen that there are bubbles forming on the side. It's just slow reacting, but it is more reactive than the aluminum is because there's a lot of bubbles floating to the top. So if I were to let the zinc sit for a while, I'm sure that it would continue to react for us to see. Okay? So now if you need to look back over that or if you have questions, let me know. But now you're going to answer the analysis and conclusion questions and then answer the assignment on its learning. When you write your definition for number 4, the definition of a metal in your own words, I want you to specifically mention how it reacts with an acid in that definition. If you just Google to find an answer, you will not get the points. And when you compare, so it all has to do with their position on the periodic table. So I have them highlighted, that's why I grabbed this. So on the periodic table, magnesium is farthest left. And that one is the one that reacted the fastest. It started bubbling right away, very violently. And then as you move right on the periodic table, they get less reactive as we go. So the zinc is more reactive than the aluminum. The aluminum had very tiny bubbles, was hardly doing anything else, but it was starting to do something. And the zinc was starting to react as well. I don't have it drawn on here, but silicon is actually a metalloid, so make sure you classify that correctly. Metalloids sometimes act like metals, sometimes act like nonmetals. So the slow bubbles means that it's kind of acting like a metal, but it technically is a metalloid if it's acting like aluminum. And then sulfur is a nonmetal, and nonmetals do not react with acid, and so that's why we didn't see anything there. So comparing how, for number 3, you could talk about how the farther left on the periodic table you are, the more reactive it will be, and the farther right, the less reactive it will be, because the nonmetals are on the right side, which makes sense. Okay, so make sure that you answer the questions on here so that it helps you for the online assignment to answer all those questions.